Welcome. My name is Robin Marsh. I'm the Secretary General of the Universal Peace Federation in the UK. I will be your moderator for this webinar today. Before we start the substance of today's webinar, I would like to introduce the technical aspects. For translation, you can click on the globe at the bottom part of your screen, and you can choose the number which relates to your language. The conference language will be English. If you're a Russian or Japanese speaker, you can choose the translation here. For questions to this eminent panel, please use the Q&A button. Now I would like to introduce Mr. Uyotani to explain in Japanese.
日本人の皆様にお知らせいたします。本日の会議は英語で進行されます。日本語の通訳をお聞きになりたい方は、Zoom の同時通訳機能を使って聞いていただくことになります。画面下のツールバーに地球儀マークのアイコンがありますので、そのボタンをクリックしていただき、お聞きになる言語を選択してください。日本語を選択すれば、日本語通訳者の音声が聞こえ、オフを選択すれば発言者の生の声が聞こえるようになっております。また質問はチャットではなく Q&A に打ち込んでくださるようお願いいたします。Thank you very much.
Thank you. Today you'll be hearing about a very significant component of a grand vision of an international highway project connecting most of the continents of the world. It was rooted in establishing a world culture of peace proposed by the co-founders of the Universal Peace Federation 40 years ago. A tunnel between Korea and Japan would have a profound effect in East Asia, peace and prosperity. And that's why this important webinar has been convened today. Let me briefly introduce the panel on your screen. Mr. Masayoshi Kajikuri is the chairman of the International Highway Construction Foundation and chairman of UPF in Japan. Dr. Yoshimitsu Nishikawa is professor of the Faculty of Regional Development Studies in Toyo University, Japan. Ms. Gozde Dizdar is the vice president of the centrist Asia Pacific Democrats International. And Professor Roger Vickerman, he is the Emeritus Professor of European Economics at the University of Kent in the United Kingdom. And Mr. Jack Marion, he's the co-chair of the UPF Europe and the Middle East, coming from France. More complete biographical detail will be put in the chat as each speaker begins to speak. First of all, giving welcoming remarks is Mr. Masayoshi Kajikuri. He is a graduate of the Sunmoon University in Korea and has served in many leadership positions of the unification movement. He is currently the chairman of the Universal Peace Federation in Japan and chairman of the International Highway Construction Foundation, of which the Japan-Korea Undersea Tunnel is a crucial part. Mr. Kajikuri, the screen is yours.
Distinguished leaders from Europe, Middle East, and Japan, on behalf of UPF Japan and the International Highway Foundation, I would like to offer a few words of greeting. First of all, I would like to thank Professor Roger Vickerman and Honorable Gozde Dizdar for sharing their knowledge and experience related to the Eurotunnel and Marmaray Tunnel, which will be great precedents for the construction of the Japan-Korea Undersea Tunnel. Although the detail of the Japan-Korea Undersea Tunnel will be explained by Dr. Nishikawa, I would like to explain the brief history of the project so that the people in Europe and the Middle East can understand this is not just an idea. We are committed to the realization of this project and it is currently in progress. Dr. Song Myung Moon founder of the Universal Peace Federation, proposed the International Peace Highway Project at the 10th International Conference on the Unity of the Science convened in Seoul, South Korea in November 1981. It is the vision of the Japan-Korea Undersea Tunnel to serve as the terminal of international highway. In 1982, the International Highway Construction Corporation was established in Japan. In terms of construction, the groundbreaking ceremony for an inclined shaft was made in Karatsu in 1986, followed by the ceremony in Tsushima Island in 2014. On the other hand, research activities have been continued since 1983 when Professor Yasuo Sasa of Hokkaido University, the leading figure of the Geological Survey of Seikan Tunnel, became the first chairman of the Japan-Korea Tunnel Research Institute. When the Japan-Korea Tunnel is completed, the total length will be 235 kilometers, 5 times the length of the Channel Tunnel between UK and France. And the Japan-Korea Summit in 2010, the two governments agreed on joint project toward a new era of Japan and Korea. As the promotion of the Japan-Korea Undersea Tunnel was included to the 21 agendas of the summit. At the end of the summit agenda description, it was said that the project should be promoted with sufficient content from the leaders and citizens of both countries, leading to the establishment of the Japan-Korea Tunnel Prefectural Councils to stimulate Japanese public opinions. Starting with the Kagoshima Prefectural Council in 2010, we could finally set up the prefectural councils in all 37 prefectures in August 2018. With many conventions and symposiums and research meetings along the way. Based on this, Japan's National Council for the Japan-Korea Tunnel was launched in November 2017 with Honorable Osamu Uno, a former member of Japan's House of Representatives, becoming the chairman together with 30 Diet members as advisors and 70 other board members joining the respective council. Also, the Kyushu Liaison Council for Japan-Korea Tunnel has been active in Kyushu region since 2015. It attempts to utilize the idea of the tunnel in solving many problems, such as depopulation, environment pollution, and so on. Some experts in Kyushu, such as Dr. Chisato Kajiyama, a former president of Kyushu University, recently published a book on the Japan-Korea Tunnel serving as an axis to how Japan is to envision the future, together with Mr. Ishii, the first president of Japan Railways Kyushu, as one of the authors of the book. Looking back on the agreement between Prime Minister Thatcher and President Mitterrand of the construction of Eurotunnel, we also aim to establish a bilateral agreement between Japan and South Korea on the tunnel project with support from many members of parliament. I hope that through today's webinar, we can all learn from our colleagues from Europe and Turkey to enhance the tunnel project in East Asia. Thank you very much for your attention.
Thank you very much, Mr. Kajikuri. Thank you. This has given us the background to understand the development of this major infrastructure project. We now have a short video that illustrates this development that has been invested in for many years. And it gives a portrayal of this, which shows much more than words.
The international highway the Japan-Korea Tunnel Project. It looks to connect Japan to the Asian continent by way of an underwater tunnel. Furthermore, it will connect with the other 5 continents of Europe, Africa, North and South America through underwater tunnels and highway systems. Through this, eternal world peace is the ultimate goal. This project was put forward by Reverend Sun Myung Moon when he presented it at the 10th International Conference on the Unity of the Sciences in 1981. In 1982, survey for the Japan-Korea Tunnel Project commenced. To begin boring, all possible surveys from land, water, and air proceeded. From 1986, excavation for an inclined shaft for underground survey began in Karatsu City in Saga Prefecture. If they succeed in this project, it would be roughly 4 times the length of the Seikan Tunnel, which is the world's longest underwater tunnel. The main tunnel would total 230 kilometers in length. In order to complete the main tunnel, they first need to dig a pilot tunnel to conduct geological surveys and for the transport of machinery and equipment used for sediment removal. One of these was the inclined shaft in Karatsu City in Saga Prefecture. So, the Japan-Korea Tunnel has many obstacles it must overcome. This project depends on Korea's effort and Japan's effort. Efforts from both sides are required. Key figures from both countries have directly indicated the necessity of the Japan-Korea Tunnel at joint studies. However, what is needed for the Japan-Korea Tunnel to move forward is the consensus of opinions from citizens of both countries. In order to gain consensus from Japanese and Korean citizens, prefectural councils for the Japan-Korea Tunnel have been formed in all 47 prefectures. The plan for the international highway will help realize the most advanced infrastructure. We cannot even estimate the economic benefits this would bring. In November 2013 in Turkey, the Bosphorus underwater tunnel opened connecting Asia and Europe. Now let's all dream of a bullet train that departs from Tokyo to Istanbul and from Istanbul to London. The time has arrived to promote the aim of the linear Chuo Shinkansen from Tokyo to London. It is not a fantasy any longer.
That video provides a glimpse into the efforts over the last 40 years that have been invested in this project already, both to establish mutual prosperity for Japan and Korea, but also to promote a culture of peace in East Asia. I'd like to introduce now Professor Yoshimitsu Nishikawa, who has graduated from the School of Law in Osaka University in 1978 and joined the Defense Agency, the present Ministry of Defense, where he served in several senior capacities. Dr. Nishikawa has been a professor at the Faculty of Regional Development Studies in Toyo University since 2002. Welcome, Dr. Nishikawa.
Thank you for your introduction. Today, I would like to talk about the Japan-Korea Undersea Tunnel project. This project will connect Kyushu, Japan and Busan, South Korea by constructing the undersea tunnel over 230 kilometers in length. What is the meaning and the value of this huge project that connects Japan and Korea with the undersea tunnel? First of all, the Japan-Korea Undersea Tunnel had a great effect on the economic development of the two countries. There is a supply chain relationship between Japan and Korea. Japanese company provide parts to Korea, and the Korean company assemble them and export finished product to the world. However, the natural obstacle of the sea lies between the two countries. If a tunnel is built, Japan, Kyushu, and South Korea will be truly one economic zone. In the future, if the railway passing through this tunnel connect the north and south of Korean peninsula and further extend to Eurasian continent, greater economic effect can be expected. The Japan-Korea Undersea Tunnel can also respond to the increasing tourism demand of both countries. Before the spread of the corona epidemic, the number of Japanese and Korean tourists who traveled between two countries exceeded 10 million. It had recorded fourfold growth over the last 20 years and will continue to grow after conquering the plague of corona. The number of passengers that can be carried by aircraft is limited. The weather condition at Genkai Strait is so unpredictable that carrying by ship can be unstable. Statistics show that every 10 days, a jet foil boat is cancelled due to rough seas. On the other hand, running high-speed railway in completed tunnel will allow a large number of personnel to be transported on time. There is no doubt that it will contribute not only to distribution of goods, but also to the expansion of tourism demand. Furthermore, if a transmission line passes through the tunnel, mutual exchange of energy between Japan and Korea become possible. The well-known Jim Rogers, one of the world top investors, said, "This project will generate huge economic value given the long-term spillover effect across the Asian region." Next, I also want to talk about the political effect of this tunnel. Japan and South Korea work together hand in hand, help each other, and join hands to build the largest undersea tunnel. Through such activities, Japan-Korea Undersea Tunnel is bringing the two countries closer together politically and encouraging policy cooperation. And the spirit of cooperation of two peoples will greatly contribute to the peace and stability of Northeast Asia. To realize through the active interaction of people, goods, and information across borders has been confirmed through the research of Professor Karl Wolfgang Deutsch of Harvard University. Deutsch is a prominent international political scientist who theorized that communication and the traffic of people and goods had a positive effect on international cooperation. His theory, transactionalism, constitutes one of the leading schools of international politics. According to Deutsch, when the cross-border movement of people and goods become active, communication networks expand, and economic transaction and exchange deepen, bringing about changes in the attitude and the perception of people. This creates a we feeling among the people of both countries in various levels. And such changes in consciousness will trigger the creation of a cross-border security peace community that will not allow war. And recently, Indian political scientist Parag Khanna has been in the spotlight. In his book, Connectography, he claimed that increasing connectivity means further growth, and that increasing connectivity transcending borders is a way to save the whole world. The increasing the cross-border interaction of information, communication, logistics, and the movement of people deepen the connection between countries, and this interconnection will equalize the stage of economic development and the gap between rich and poor. Kanna say that if this connection becomes global, middle class globalization or middle classification of the world is possible. And to do this, it's necessary to carry out projects such as international highway and undersea tunnel to connect continents separated by ocean, and develop communication infrastructure which connect country to country and continent to continent. Theory of Deutsch and Kanna explain the peaceful significance of the Japan-Korea Undersea Tunnel. In recent years, globalism, which had played at the end of Cold War, to be overshadowed, and now countries are raising their national border again. With the confrontation between US and China, anti-globalism is getting stronger. However, denying globalism and prioritizing the interest of one's own country is by no means desirable in achieving world peace and stability. At a time when the threat of anti-globalism is on the rise, it is necessary to take measures to enhance cross-border interaction, such as the Japan-Korea Undersea Tunnel. The cost of constructing this world's largest undersea tunnel is estimated to be around $100 billion, and the construction period is about 10 years. Japan has involved in the construction of large tunnels, such as the Seikan Tunnel, the Dover Channel Tunnel, and the Bosphorus Strait Tunnel. Given these achievements and high-level technology that Japan has, construction of Japan-Korean Undersea Tunnel is technically feasible. Now is the time to make efforts that will realize this projection. I would like to ask all of you for your understanding and support of the Japan-Korea Undersea Tunnel project. Thank you for your time and attention, indeed.
Thank you, Professor Nishikawa. I think that's a wonderful explanation of the economic and social connectivity and the values that it brings for not just peaceful relations between individual nations, but can extend throughout the world if this vision for an international highway can be fulfilled. And this globalization of middle class is a wonderful idea. Our next speaker also is going to speak about connectivity, but not just between two nations. It's actually two continents bringing together in one city, Istanbul, the capital of Turkey. The Marmaray Tunnel in Turkey drew together the continents of Europe and Asia across the Bosphorus. To explain the impact of this tunnel is Gozde Dizdar, who is the Vice President of the Strategic Partnerships for the Centrist Asia Pacific Democrats International, as well as the founder and managing director of Governance and Development Global. She is also chairwoman of the Youth Committee of the Global Party's Climate and Ecological Alliance. Ms. Gozde Dizdar, the screen is yours.
Thank you very much. I just wanted to also make a presentation through a PowerPoint. But first of all, kind regards from Turkey. And thank you very much again for this very valuable webinar of today. Just please let me. So you can see the presentation, right?
Yes.
Okay.
Okay.
Okay. So our topic today is toward an undersea tunnel connecting Japan and Korea, lessons from Eurotunnel and Marmaray Tunnel. And with my best capacity, I would like to explain you what was the points regarding this Marmaray Tunnel. As we all know, geography and transportation intersect in terms of movement of people, goods, and information, and creates valuable links between regions and economic activities. But on the other hand, rapid growth in population has created problems in transportation. So when it comes to Istanbul, we name it one city, two continents. And Napoleon says that if the earth were a single state, Istanbul would be its capital. So it's the city in the world between two continents, Asia and Europe. The city which has seaports of industrial and financial centers, crossroads between East and West, North and South for centuries. And it's the southeastern tip of Europe, separated by Asia with Bosphorus. And Black Sea and Sea of Marmara is also the part of the city. So the Marmara project is the most prestigious projects of Turkey connecting Asia and Europe. But at the same time, it provides continuous railway from Peking to London. And of course, it includes upgrading of commuter system at Asian and Europe sites in Istanbul, and construction of its central element being in a railway tunnel under the Bosphorus. The deepest immersed tube tunnel in the world with 60 meters. And the travel time between Asia to Europe is only 4 minutes. As you can see from the chart, I'll also explain this in detail. From clients to financial organizations, contract type, there are a lot of counterparts. But I wanted to share this because the contract amount, the estimated was $5 billion, whereas with the additions, the estimated cost is thinks to be like $8 billion. So the immersed tube, bored tunnels, the underground stations, surface stations, as you can see in this chart, is all about the process. But let's start with the historical background of the project. Because the first idea was in the time of Ottoman Empire, 1860s, and even a design was shaped. But following to date, in 1902, another similar project was put on the table, which is called Tünel-i Bahri. But neither the time nor the technology permit the construction of these projects. So still from our libraries, from our documents, we can see the first drawings. The first reality, the first research regarding this in Modern Republic of Turkey starting in 1985 by Istanbul Rare Tunnel consultants, and factors like from urban land use characteristics to historical and ecological resources, from like transportation characteristics, pollution, noise, water sources. Actually, a lot of things are being considered as a sensitive points of this project. And also why Turkey again, like in the end of 80s, put this on the project is, I think, best can be understood from this chart. Because as you can see, the population change in Istanbul, especially if you can notice that in 1985, it was roughly less than 6 million. But when the first chapter was put in reality, it was already more than 10 million. So it was a basic need. And in 2000, the official process of construction, like the tenders has started. And of course, the project was based on modernization of existing commuter railway systems, renewal of stations, implementations of tubes and under the Istanbul Strait to connect separate railway systems. So everything was designed in different phases. During this time, again, I wanted to share with you the population change in Asian and European sides of Istanbul. And from 35 to 2010, you can see that each and every year, the change was growing. So again, this made the facts made this project one of the basic needs. So the initial Marmaray phase was opened to run in the line from Söğütlü Çeşme to Kazlı Çeşme in October 13. But the first date of the opening was 2009. The delay of the 4 years was mostly due to the archaeological findings. And also the modernization of the renewal of the existing railway system started in 2012, but it was announced to finish in 24 months, 2 years, but it took almost 5 years because of the crisis and losses in mega budgets. So you can see from this chart, timeline of developments of urban transportation in Istanbul. It really starts from end of 1851, but the finalization is in 2019 with the opening of the second phase of the Marmaray. So when we come to the more technical sides, I want to give you further information because Marmaray is kind of 3 separate contracted projects. First contract is BC1, constructing of 1.4 kilometer immersed tube under the Bosphorus. And the second contract is CR3, upgrading the 62.7 kilometer that is the existing 8th grade commuter system, but completely new technical and mechanical systems are installed. And the third one, contract CR2, provision of 44 trains and cars. If we have a closer look, you can see that from European side to Asian side, the total length is 76.3 kilometer, and tube tunnel approaches on 12.20 kilometer, together with tube tunnel 1.4 kilometer. So Bosphorus Strait, European side and Asian side, you can see from this chart, is connected. But of course, every stage has many challenges. So I also wanted to show you the strong and weak sides and challenges faced during the process as well. First challenge, the Istanbul Tunnel Strait, the deepest built so far, but its deepest point is 58 meters under the water surface. And the seismic design of the immersed tunnel was one of the most critical elements because of tunnel's proximity to the seismic fault system, which is only 16 kilometers away. So this was one of the main challenges. Another one was the marine works are carried out in very deep water, and 50,000 ships pass every year. The immersion operations are carried out in the stratified currents of the Istanbul Strait, where the upper current velocity reaches up to 5 knots. And the deep stations and tunnels are constructed in the area where civilization can be traced back to 8,000 years. And of course, preservation and rescuing the historical heritage was a special focus point as well. For the technical challenges, earthquake resistance, 7.5 on Richter scale, water tightness of concrete elements, trench dragging on compaction grouting under Bosphorus, placing each tunnel element, and geotechnical monitoring was part of some technical challenges as well. In here, you can see the stations in Asian side, European side, and also another one in European side as well. So when we come to the third phase, contract CR3, we can see that it's mostly about upgrading 62 kilometers. And there are also 38 surface stations and also reconstruction of 160 highway, pedestrian, overpass, and bridges. So also you can see some samples of the stations and control center together with the transfer station as well. So we say that historical heritage of Istanbul was one of the main challenges itself. And archaeological investigations have been conducted by Istanbul Archaeological Museums Directorate, of course, in coordination with the ministry. So we found out footprints of first civilizations, which was even dating back to 8,500 years ago. And the discovery of Neolithic settlement in Yenikapı declared this officially. And you can, from this chart, see that archaeological and built heritage receptors of Marmaray. This is also one of the historical buildings that is preserved and restored. But for me, one of the very important maps is this one, because this is UNESCO World Heritage Site designation of Marmaray. And after the discovery of the archaeological findings, Istanbul is even nominated as the European Capital of Culture in 2010. So when we look at the time chart from year 1985 to, as we declared before, to 2019, each and every step has its strong and weak sides within itself. But when we look at the Marmaray at a glance, it is 100-year design life. It's an immersed tunnel, TBM bored tunnel, NATM tunnel, and cut-cover tunnel methods are used. Of course, from electrification system to speed trains, the top technologies are used during the project. When we come to benefits of project, provide long-term sustainable solution to transportation problems of Istanbul. It connects Asia and Europe, reduces impacts of traffic, and from degrees of pollution to like degrees travel time for 1 million people every day, it has other strong sides. When we come to the fundings and contracts, I think we wouldn't do this project without the support of our Japanese friends, brothers and sisters, because Japan Bank for International Cooperation, of course, together with European Council Development Bank and Investment Bank, gave Turkey the loan. We can talk about 4 separate packages: engineering and consultant services, the Bosphorus crossing contract, which was a joint venture formed by 4 partners from Turkey and Japan, and Taisei Cooperation from Japan, which is the lead partner, as was really the experience in tunneling works. Also, Kumagai from Japan and Asia involved in many projects. Gama from Turkey and Nurol was also the partners. So from this chart, You can also find the scope and company and the contracts as well. Again, the third phase was commuter rail infrastructure and systems contract. And the fourth one was the rolling stock contract. Finally, before I finish my presentation, of course, Marmaray is a very complex and multidisciplined, multifunctional process. So I think one of the strong sides of the project was making project risk management from conceptual planning to post-construction in each and every stage. And I think risk management system was the strongest. You can see a sample of Üsküdar station here. And I want to also share some photos and some drawings of the immersed tunnel and turnback tunnel from the TBM tunnel from this chart as well. So I wanted to summarize my presentation now by concluding what happened actually. Of course, the challenging part was archaeological findings, and we design changes happened. Geological risk and structural damage, reaction from people, unsolved buildings, of course, made a huge delay. Archaeological findings, of course, the bureaucracy within the country and outside made a delay. And also, so to say, this was a mega project. So inside the country, there was also a political pressure as well. But at the end of this, Marmaray became one of the mega projects, and we consider it as not only a unique project of Turkey, but just like Istanbul, it's part of the World Heritage now. So thank you very much for listening to me, and kind regards.
Thank you very much for your presentation, Gozde. Thank you. I think it's amazing the cooperation with Japan already and the technical skills that Japan has. I can see to create a tunnel with 7.5 Richter scale seismic activity protection. That shows an amazing level of engineering skill. It's now my pleasure to introduce Emeritus Professor Roger Vickerman, whose academic career has provided a vantage point to observe the ups and downs of the other tunnel that we're looking at today, the Eurotunnel. As a professor of economics in Kent University and the chair of the Transport Strategy Centre of Imperial College London, he has advised the UK government, the EU Commission, and numerous other bodies on transport policy and infrastructure development, particularly focusing on high-speed rail projects. Welcome, Professor Roger Vickerman. The screen is yours.
Thank you very much, Robin. And I'm very, very pleased to have the opportunity to be able to talk to you today on this project. My presentation comes with a warning. I'm an economist, and therefore I will probably put a little bit of dismal science onto the enthusiasm that's already been shown in this project. And I want to talk about the Channel Tunnel, the Eurotunnel, and see what lessons might be learned from this. And the important point about this is to find what can be done in the light of the experience with the building of an international tunnel, the Channel Tunnel. To remind you that the Strait of Dover, which separates Britain from the continental Europe, is 33 kilometers wide at its narrowest point. So it's very small. And it's important to remember that until about 8,500 years ago, the island that is now Great Britain was part of the European continental landmass. It was only at the end of the last ice age that the water was separated. So those people who say that Britain is separate from the continent and should always remain so, of course, are looking at a very short period of history indeed. The tunnel system that links Folkestone in the UK and Calais in France is a 50-kilometer long tunnel, including the bits that go under the land. And it involves 2 running tunnels and a service tunnel. There are two types of service, all provided by rail. So there is no drive-through system on the roads. There are shuttle trains for cars and trucks, and there are through rail services, Eurostar high-speed trains run between London, Paris and Brussels, and there are through trains to Amsterdam and Marseille, plus one or two other services that serve the French Alps during normal times of skiing and so on. And there are unfortunately limited through freight services through the tunnel. Now, like most of these schemes, it's nothing new. The first scheme was dreamed up in the middle of the 18th century by a man called Nicolas Desmarais. But the most serious first proposal was 1802. It was proposed by a French engineer called Albert Thomas de Gamond, who was an advisor to Napoleon. Given the state of Europe at the time, of course, a proposal from Napoleon to link to the United Kingdom was not taken with any great enthusiasm this side of the Channel. What's interesting here is there were 26 further proposals all the way through the 19th century and right the way up to the start of the current proposal, the current system in 1985. Work actually started on building two competing projects in the 1880s that were then cancelled on military and defence grounds. And what was interesting about this was that although it was thought that invading armies could come marching in, of course, if invading armies promised that they would only enter via a tunnel, then that would be a very easy thing to defend, much more difficult to defend seaborne invasions. And in fact, the projects which had been deemed by Lord Palmerston in the 1850s to be something that he couldn't see why anyone wanted to shorten a distance that was already, in his view, far too short. That proposal remained on the table. And in fact, people argue that the First World War might have been completed 2 years sooner than it was, at the saving of many thousands, hundreds of thousands of lives, if a tunnel had been there to provide logistic support to the troops in the trenches. But the first serious Anglo-French proposal came back in the 1960s, although that was cancelled in 1975 on cost grounds, was renewed in the 1980s. And interestingly, at that point, it was believed that this shouldn't be a public sector project, but it could be funded by the private sector. In particular, at that time, the world was awash with considerable amount of liquid capital, particularly in Japan, before the Japanese economic miracle rather slowed down in the 1990s. And so it was believed that this money could come forward and fund it. And of course, that was music to the ears of Margaret Thatcher when she came to power in 1979. A private sector showcase to show that this could happen, and that it would involve a competition. There would be a competition to decide who would design the best fixed link, which could involve a bridge, could involve a combination of bridges and tunnels, could involve drive-through schemes, or could involve the scheme that essentially had been the one on the table all the time for a railway tunnel. And the decision that was taken in 1984, following the Fontainebleau summit of the European Community, was seen to some as a commitment to Europe by the UK. So it was an important political system. What happened was that the Eurotunnel system was chosen as less as a 55-year concession, subsequently extended because of financial problems, and it was an Anglo-French consortium called CTG-FM, Channel Tunnel Group France-Manche. That was a consortium of construction companies and banks, which then let itself a construction contract, the same group of companies. And the project was authorized in each country according to its own procedures. But again, as has already been mentioned, there was an international treaty. The Treaty of Canterbury was signed in 1986, and that still provides the legal basis for this international project. There are international authorities to monitor the project, particularly safety grounds, though that is subject to renegotiation following the United Kingdom leaving the European Union because of the absence now of common European law. Formally, no public money was put into the project, but both countries brought pressure to bear to ensure the project was completed. So to say that it was a purely private sector project is perhaps a little too far. But of course, tunnels are expensive and unpredictable, often underestimated. The total cost was about double the 1985 estimate by the time of the tunnel's opening in 1994. And the biggest increases were in the specialist rolling stock, not least because the International Safety Authority decided that it needed more strict safety precautions. This, of course, being a time when the rise of terrorism was thought to be a major threat to the system. And the project had to be refinanced several times. The canny Japanese investors sold their dwindling element of equity in the project to unsuspecting Americans during one of the refinancements. But nevertheless, the tunnel did get open in 1994, only about a year after the original time. So it was kept more or less on time, but at a very high level of cost. Now, if predicting the cost of building a tunnel is difficult, forecasting the usage of them is notoriously difficult, and particularly when they're rail projects. Optimism bias tends to overestimate. The average shortfall on estimates of rail projects and big rail projects is around 40%. So there's always a belief that these will carry more traffic than they actually do. And there are particular problems with international projects. People don't behave the same way across borders as they do within countries. And it's difficult to make comparisons. Every single project is unique in its own way. So if you compare the Channel Tunnel, the Öresund link, the forthcoming Fehmarn link, the Istanbul link we've heard, and of course the Japan-Korea tunnel, each is unique. It has its own characteristics. Concerns on safety and security, the response of ferry companies on fares and capacity. Did they behave rationally in this as they increased capacity and reduced fares to try and bankrupt the tunnel? The growth of low-cost airlines, which provide direct region-to-region services. And that is an important thing to remember, that aircraft, although they are smaller, as has already been suggested, they at least can provide direct links from where you are to where you want to go, rather than having to go through a complex rail system. And of course, a particular problem here is the through rail freight, which would be a great boost to take trucks off the road, has failed to match the forecast because the European rail system has not yet really got rid of the borders between the various countries. Just to show you some graphs on this, you can see that initially it was hugely successful, big growth in traffic, both on the tunnel and on the ferries. And it looked as if the 1982 forecast of total cross-channel traffic was going to be met by the year 2000. But then things started to fall away and stabilize. Dips in 2008-9 with the global financial crisis. And although the ferries have gradually declined over the period, the rate of growth of traffic through the tunnel has not been as great as people might have expected. The through rail services carry probably less than half of the forecast traffic that was made. And of course, during this time, air traffic continued to grow. This is just traffic between the United Kingdom and the 5 nearest countries in continental Europe. And that has continued to grow, so that whilst about 10 million passengers carried by Eurostar, about 10 million passengers carried by each of the tunnel and the ferries between Britain and France, around 10 million passengers are also carried by airlines between Britain and France, many of them not going to Paris, but going to places further away. The number of vehicles traveled is slightly different from that, and it shows that the tunnel has now taken the largest share, around 60% of the market share. But on truck traffic, that did grow faster than was expected, particularly following the completion of the European single market in 1992. Freight traffic growth between the United Kingdom and continental Europe grew remarkably over that period, and also concentrated very much on these short sea crossings through the port of Dover and Eurotunnel at the expense of some of the more marginal ferry routes that exist around the country. But total rail freight through rail freight has been very disappointing. It had been estimated around 6 million tons would be carried a year. It got in the first few years up to 3 million tons, but it's barely struggled to be over 1 million tons in recent years. And that has been, again, a failure to be able to provide the flexibility that truck traffic does for consignments. And so most of this traffic is block trains, for example, for automobile manufacturers and so on. So there is a problem there. After the initial growth, Eurotunnel struggled a little bit financially, but recently has managed now to increase its revenues and stabilize them with a sophisticated yield management system. And I've only taken this data obviously up to 2019, as 2020 was, of course, a disastrous year for all transport operators. And interestingly, Eurotunnel has diversified from being just the operator of a tunnel into being a multi-dimensional company, now calls itself Getlink, and it has also invested in power cables and so on taken through the tunnel. Let me turn now to looking at the economic impact of the tunnel. Because of the private sector nature of this, there was no official ex-ante cost-benefit analysis. There had been one earlier in 1982, but on this project, it was to avoid influencing the investors. And the initial assumption was that increased accessibility would benefit the regions closer to the link. Investment in the rail and road infrastructures that were made by the two governments made the tunnel one element in developing European networks. And I think that is an important point to remember, as was highlighted right at the beginning of this webinar, about the importance of linking these things into networks. But the more detailed analysis suggests that the benefits flow more to the major metropolitan areas. London, Paris, Brussels have all shown benefits from this. The coastal regions and the intermediate cities effectively become bypassed by this. The need to stay overnight before taking an early morning ferry has gone with the existence of speeding up of these services. But if you think about this as being one small element in our overall European system, the overall impact on European accessibility is small, and the benefits get very widely spread. Macroeconomic impacts shown already how the 2008-9 recession impacted very much on flows. And there's also the question of how long does the economy take to adjust? Does it take 5 years? Does it take 10 years? Or does it take 20 years as people absorb new opportunities? If we look at the growth of gross domestic product in the regions close to the tunnel, we can see that the major beneficiaries were Paris, Brussels, London. Within my region of Kent, where I'm based, it was the regions closer to London that benefited from the pull of the London economy, not the regions closer to the tunnel. So here we see the blue line is the performance of East Kent, which is the area closest to the tunnel. So growth didn't work terribly well. And these regions have actually lost out relative to the European average, have lost out in terms of their overall performance. Brussels, London, and Paris have all remained very, very rich relative to the European average, but the regions both in the French side, Pas-de-Calais and East Kent, are the two poorest regions. They're the ones closest to the tunnel. So it doesn't bring an automatic benefit to regions that are close to a tunnel, which is actually linking much wider systems into place. And this is just another way of looking at the individual districts of Kent. So it's places like Sevenoaks, Tunbridge Wells, and Dartford were the ones that showed the greatest growth in this case, gross value added per head, whereas places like Dover and Shepway, which is Folkestone, performed less well in this area. So being close to a an activity like this doesn't guarantee you any benefits. And the wish of the then British government not to put public money, except at a very minimal level, into the system, actually prevented really being able to take advantage. Not least to say, of course, that there was a degree of skepticism and reluctance particularly on the British side in Kent, to accept the tunnel as something that they could build an economic future on. So what do I conclude from this? Traffic and the impact of major infrastructures are notoriously difficult to predict, especially when they're international. Lessons from the Channel Tunnel are complicated by its private sector status, albeit there were some public elements. The political will is essential, but it can complicate objective analysis. And would more sophisticated modeling have helped? Well, probably not. However sophisticated your modeling, you would probably miss out when you're predicting something as large as this. So was it a mistake? And if so, for whom? Trying to build a balance sheet of this. Well, the people who lost out were the initial investors. They're the ones who saw their equity reduced, and they saw that the debt was also diluted. The lenders were compromised in this system. And that's not atypical. It happened in the private sector development of the railways in Britain in the 19th century. The initial investors lost their money, but what they left was an infrastructure that could be used. And that is the major benefit for this. The users benefited from competition, which kept charges lower. They made time savings. It's on the shuttle trains, passenger shuttle trains, 35 minutes through the tunnels compared with 75 minutes on a ferry, 20 minutes on the Eurostar train going through the tunnel. So it brought London to Paris and London to Brussels within that magic 3-hour city centre to city centre limit. Competitors, the ferries lost, but they actually concentrated and kept their fares lower. The airlines were able to compete effectively, particularly the newer low-cost airlines that came in the 1990s, EasyJet, Ryanair in particular in Europe. And except on the London-Paris to Brussels link, there is a diversity of where people go. What about the neighbouring regions? They benefited a little bit from some compensatory investments, high-speed rail links, train from Canterbury to where I live to London now takes less than an hour as opposed to 90 minutes prior to the tunnel. And the high-speed link only came into existence because of the tunnel. Some road improvements, but the little long-term impact on what were relatively poor regional economies that don't have any great advantage in competing, and some negative effects. But the failure to engage on the UK side, the general reluctance to accept this, the general fear that, you know, it was something that was against the nature of God to connect Britain to France, still prevails. And of course, one can see that in the fact that these regions, with the exception of Canterbury, where I live, all voted very, very strongly in the referendum in 2016 to leave the European Union. And that is, in my view, a major mistake. For the UK as a whole, improved access of London to the near continent supported an increase in trade. Some possible negative impacts on northern regions through the concentration of traffic through the Dover corridor because it was more competitive meant that they lost out on that. But still, some of the longer distance ferry routes, such as those through Hull and Portsmouth, have maintained. What about for the EU? The benefits associated with the trans-European transport networks integrating the EU economies, and the potential political benefits of binding the UK strongly in, having grabbed Mrs. Thatcher's enthusiasm in the 1980s and linking Great Britain physically to the continent, has of course somewhat been undone by Brexit. There were attempts to build a cross-channel Euro region. It's only been partially successful as that, though there have been a lot of smaller benefits from this. My own university in Kent developed European postgraduate centres in Brussels and Paris that essentially were supported by the fact that we could use Eurostar to go between the two. And there are many other examples of linking on a small scale basis towns and villages across the channel to build something, given that the geology was common on both sides of the channel, trying to bring people together in those areas was seen to be important. So it's a mixed picture in terms of this. Now let me just conclude. To make a formal sort of balance sheet of this poses serious methodological problems, but effective writing off the initial construction debt means Eurotunnel is now a profitable concern. The through rail services have been less successful, particularly for freight. With the collapse of traffic during the current pandemic, Eurostar is now in a dire financial state. The overall economic impact is finely balanced, some gains, some losses, but there's been little lasting legacy attempts at genuine cross-border integration here. That mutual suspicion, I think, remains on both sides of the channel. But the unique character of an infrastructure project like this limits lessons for other projects. I think, as say with some confidence, that all forecasts of cost and traffic will be wrong, because they almost always are. But that doesn't mean that one should not go ahead with these ambitious projects. What is important is to ensure that all the political parties are signed up to it and recognize that just building a piece of infrastructure doesn't mean that the benefits will just come cascading in. You have to earn them, and you have to earn them by putting in place some other policies around that support the tunnel. Thank you very much.
Thank you very much, Professor Vickerman. That was a wonderful analysis. If I could ask you one question, now we're going to start question and answers, since you're on the screen. Just if you could advise our Japanese colleagues who are promoting and being passionately promoting the international, the Japan-Korea Undersea Tunnel, what advice would you give them for promoting the project?
I think the important thing is to make sure that you have very clear support from a range of stakeholders, and that involves both national governments and the local governments in the areas that are relatively close to the project. One of the big problems in Britain has been that with all big projects, we face a problem that there is a huge amount of negative publicity given to anything which links internationally, and particularly anything which is seen to potentially being destructive of the environment. And so that there are also important environmental concerns to bear in mind. And I think that's important in terms of thinking as well about whether this should be a road as well as a rail project, because road projects create many more problems in terms of designing them successfully, but also trying to use the most environmentally efficient means of transport is an important element here. Those I think are the key things. It's about building that consensus, which was difficult to do in the tunnel case, channel tunnel case.
Oh, thank you very much. I know as someone who's used the Eurostar from time to time, the convenience of it to get on a train and in a couple of hours you're in Paris or in Brussels is an amazing thing. It's from center of London to center of Paris. The queues and so on are much shorter compared to air. But I wanted to now ask a question to Professor Nishikawa. Professor Nishikawa, you gave us a very optimistic viewpoint of the effects of the international highway as a whole, and also the Japan-Korea tunnel. But given that it has been put on the agenda for a joint project between Japan and Korea in 2010, and given that we have now strong support from the mayor of Busan. What is your assessment of when this tunnel may happen?
Thank you for your question. The first step is to overcome the corona disaster. After that, the framework for regular consultation between the leaders of the two countries will be restored, and in-depth dialogue will be possible. And Japan and South Korea's share of the expected $100 billion cost of construction is yet to be decided. Secondly, it is necessary to budget for a study of the tunnel construction project based on Japanese budgetary system. So I think that this process will take at least 10 years or so.
Do you think 10 years to get a consensus and to be able to start? But even so, that's an amazing view for the future for the younger generation coming up. Their future and the connection there would be an amazing development. I would like to now ask Gozde Dizdar. You gave us a wonderful presentation of the development of the Bosphorus, the Marmaray tunnel across the Bosphorus. And one thing we want to ask is, what is the key to the technological success of the world's deepest immersed tube method? This is one question that's been asked. And the world's first technology for connecting shield tunnels. What kind of danger also did it bring?
Actually, the answer to this question is made in Japan. So we were very also proud that, as we said, one of the constructors, actually the biggest partner of this project was a company from Japan. Of course, it has some Turkish parts as well, but 60 meters below the sea level, let's say, it's the deepest immersed tunnel in the world. And shield tunneling method was one of the methods used. But when we consider the amounts of water and also solid were flowing into the excavation pit, the engineers also decided to use temporary sealing technique of ground freezing to get the tunnel boring machine with a diameter of almost 7.93 meters safety to target excavation pit, and liquid nitrogen was introduced in drill holes around the area of the tunnel boring machine as well. In other words, actually connecting the Asian and European sites, different methods and systems are used. But we should, I think, underline that the total of 1.3 million cubic yards was dragged out of the Istanbul Strait and carried to a confident disposal site that is created specifically for the project. As I said, the engineers also used free resistant concrete that was developed in Norway to enhance the safety as well. So when we say actually it's a unique example of its field, we cannot talk about one unique techniques, but actually it was the putting together the best practices.
Thank you very much. I'd like to ask Professor Vickerman, how was the construction cost collected? Assuming from a Japanese perspective, it was saying apparently about 1.9 trillion yen or 14 billion euros was raised for the Eurotunnel project. How was it raised from around the world, and what was the funding platform and strategies?
The first thing to note was that it was decided that it would be a mixture of equity and loan finance. It was seen as being very important in a project that contained a considerable element of risk, that there should be equity holdings in this because it was a large-scale project with a considerable amount of risk involved with it. That was raised in a series of tranches, with the first major public launch in 1987. But at the time, there were still some considerable doubts over the final approval by the UK Parliament, because it had to go through a parliamentary process to be finally approved. And also the escalating costs that arose. The Channel Tunnel I didn't mention, but the Channel Tunnel is a bored tunnel project, not an immersed tunnel project. And immediately construction started. Despite very good understanding of the geology, they ran into problems which raised the cost, although the tunnel boring cost was not the biggest increase in the cost that was involved. The most important part in this was what was effectively a private company, albeit a consortium of companies, had to have very strong leadership. And it did have very strong leadership through a man called Sir Alistair Morton, who led the project. And of course, he spent a lot of his time actually firefighting the concern, particularly from Japanese investors, that the British government wasn't sufficiently behind the scheme. And so that he had to spend a lot of time assuring the Japanese investors that the UK government was in fact behind the scheme, despite the fact that the UK government was trying to say, oh no, it's a private sector project, we can't get involved with this. And so that was a particular problem of the tunnel. But with all of these projects, refinancing is important. And when it's a private sector project, that becomes even more difficult, which is why the Bank of England and the Banque de France were also very strongly involved in trying to reassure investors that this was a project that did have some residual support from the governments.
Thank you. Thank you. There's a question from Russia for Professor Vickerman. It says, Great Britain and has there been any loss of cultural heritage involved in the tunnel? Great Britain and France historically protected themselves from cultural influence on each other. You come from Kent.
Well, I have to say, I live in Kent, but I'm a northerner, and I have very strong cultural traditions in my home county of Lancashire, which are interesting. I think the simple answer to that is no. That there had been all the time this view that Europeanization and European integration would lead to some sort of loss of cultural heritage. But it's very clear that cultural heritage remains at a regional level throughout Europe. Talk to a Bavarian and they will claim that they're very different from someone from Berlin. Talk to someone from Marseille and they will say that they've got nothing in common with someone from Lille. So those regional dimensions, I think, remain within countries. What I think is important here is that there have been very strong attempts to try and bridge the gap between close Britain, Kent in particular, and the northern part of France. And they have worked a little bit. And there have been attempts to set up very important sort of cultural activities and so on, joint historical activities, joint tourism activities. But they haven't really got over the fact that we are divided by language. And that ultimately becomes, particularly because, as you know, the British are hopeless on the whole at any other language, including their own very often. And so that this acts as a brake on that. And I have to say, with all due respect to the French participants in this, the French are not a great deal better at breaking down that cultural barrier. But I mean, we haven't lost that identity. There's always been this fear of a loss of identity, but it really doesn't work with that. You need more than that to break down cultural barriers.
Thank you very much. Just one more question for Dr. Nishikawa. A question here is, what are the foreseen steps to get the support from many members of the Japanese Parliament for this tunnel? What is the plan for your development of stronger participation of the Japanese Parliament and government?
Thank you for your question. In order to gain the support of more MP politicians, I believe it is important to gain the broad support of all sections of the public for this tunnel project. So this will require more publicity and education about the tunnel project and its significance. I think so. These activities will get more support from MP.
Thank you. And a question for Gozde. You mentioned that the excavation of ancient remains interrupted construction many times. What kind of trouble did that cause?
Actually, the first stage of Marmaray project was supposed to end of April 2009. But during the construction, as I said before, number of archaeological ruins discovered, and the project was planned in, of course, parallel with this archaeological studies within the area. So it is postponed a number of times, and each and every delay, of course, had its own costing. For example, the first one, the major one, the estimated cost of the delay is $500 million. But of course, we are talking about number of delays of the projects. But I think on the other side, from my point of view at least, even though construction is interrupted, even though the delivery of the project has to be postponed, there was also some positive outcomes as well, which is like one of the points is, before a lot of historians, a lot of archaeological findings were dating Istanbul's history back to 4,000 years. But in one of the major findings discovered a grave, and it was dated back to 8,500 years of history. In one of the stations, there is now a museum, and there is an exhibition of all these findings. And this also made Turkey and Istanbul nominated to be the European capital of culture in 2010. So for sure, from the economical perspective, it has its own cost. And of course, within the construction, because of the delays, because of the using of the motivation, because of ongoing changing plans, ongoing changing strategies, feasibilities, it has some very negative impact. But on the other side, at the end, I see Istanbul as a world heritage, and UNESCO also declared Istanbul as a World Heritage, special thanks to these findings as well.
Thank you. Unfortunately, we've run out of time for further questions. But thank you very much for those answers. I would like to turn now to Mr. Jacques Marion for the concluding remarks of this webinar. He is the co-chair of the Universal Peace Federation in Europe and the Middle East and president of UPF in France. He has had leadership positions within the unification movement and Universal Peace Federation from Africa, China, Eurasia, and now Europe and the Middle East. Mr. Jacques Marion, the screen is yours.
Thank you, Robin, and thank you very much, Professor Nishikawa, Madame Dizdar, and Professor Vickerman, Mr. Kajikuri. Thank you very much, dear participants. I sincerely thank you for your very insightful and very interesting presentations. The Japan-Korea Tunnel, as we see it, is an idea whose time has come, and the knowledge you've shared with us today is very much appreciated. In my brief remarks, I will focus on the vision behind this project, which is one of the core objectives of the Universal Peace Federation. As mentioned by Mr. Kajikuri, our founders, Dr. and Mrs. Moon, introduced this project 40 years ago in 1981 during the 10th International Conference on the Unity of Sciences in Seoul, Korea. The Japan-Korea Tunnel is meant to be the first link of a great international highway that would run through China to the west and Russia to the north, helping to create a prosperous East Asian economic zone. It would then reach out to Western Europe on the one hand, and to the USA and Canada on the other, by means of an undersea tunnel at the Bering Strait, which is, as you may know, a project that was first proposed more than a century ago. This highway system would foster mutual prosperity, not only between East and West, but also between North and South, reaching the southern tip of Africa at one end and the bottom of South America at the other. Therefore, our founders described this project as an international highway for peace, connecting the world from the Cape of Good Hope to Santiago de Chile and from London to New York. They envision it as a modern-day global Silk Road that would foster economic development, cultural exchange, and the reduction of regional inequalities. The Eurotunnel and the Marmaray tunnels, which we discussed today, would of course be key links on this worldwide highway system. But there are two specific challenges in this grand project that underscore the name Highway for Peace. One is the tunnel between Japan and Korea, and the second, the tunnel connecting Russia and the United States at the Bering Strait. In both cases, as we know, the project implies overcoming decades of hostility inherited from 20th century conflicts between two nations. Yet, again, this is an idea whose time has come, and it is already on the discussion table of politicians. It's significant that recently the new mayor of Busan, the second largest city in Korea, at the southern tip of the peninsula, declared that he was supportive of the Japan-Korea Tunnel project, undoubtedly for many of the reasons mentioned by Professor Nishikawa today. Studies have also shown that the economic benefits for the world of a transport link at the Bering Strait. According to Dr. Raj Begin, the leading researcher on this project for many years at Russia's Transport Ministry, the intercontinental link at the Bering Strait would significantly shorten the freight transport time between Asia and America, thus highly benefiting trade among the great economic powers of the region. Russia is accelerating the development of its transport infrastructure in Siberia and its Far East region. Already in 2007, Russia included in its transport development plan until 2030 the extension of its railroad system up to the shores of the Bering Strait. A key obstacle for this project, of course, is the current division of the Korean Peninsula. Without an open border between North and South Korea, the Japan-Korea Tunnel loses a lot of its significance. A trans-Korean railway project between North and South Korea came shortly to life in 2007, but was stopped in 2008. We can only hope that North Korea's pressing needs for economic development, which is a new focus of the regime, will be an incentive to resume cooperation. The purpose of this conference, ILC 2021, which we are starting today, is to garner the support of experts to discuss conditions for a peaceful solution to this division of the Korean Peninsula. So the information you shared on this webinar has greatly contributed to this discussion, and we sincerely thank you for this. The Japan-Korea Tunnel, the International Highway for Peace, are actually founding projects of UPF, as they embody our core principles of interdependence, mutual prosperity, and universal values. Therefore, I sincerely wish that I can experience one day, before the end of my lifetime, traveling by car or train between Korea and Japan. As a Frenchman, I can guarantee that having London just 2 or 3 hours from Paris by express train is an unbeatable way of traveling. And it's a privilege that I'm sure no one on either side of the channel will ever want to lose. Thank you very much for your attention.
Thank you for those insights, Jacques-Marian. We really appreciate all of you who have attended today's program. We look forward to a time when Korea and Japan are connected with the undersea tunnel. We in Europe, we look forward to a time when we can drive or take a bullet train from London, Paris, or Berlin and visit Pyongyang, Seoul, and Tokyo. And then we can truly experience what it is like to be one human family living in peace and prosperity. With that, I'd like to ask the panelists to all appear on the screen. And if we can smile or wave as we say goodbye to our audience.
Thank you.
Thank you very much, everyone.
Thank you. Thank you.
Thank you very much.
Thank you, everyone. Thank you. Thank you, Robin.
Thank you. Thank you.
Thank you very much, everybody.
Thank you, Dr. Otsuka.
Yeah, thank you.
Thank you.
Thank you very much.
Thank you very much indeed.
Thank you, Professor Vickerman.
Professor Vickerman and Mr. Nishikawa, Dr. Nishikawa, and others.
And Gozde.